Hi, this is Tom. And in this lesson, we are going to learn about the exponential function. So let's see. So far, this is what we've done so far. So far, we've looked at problems that look like this. For example, y equals x, or maybe y equals x squared, or possibly y equals x squared minus x plus 1, and all sorts of variations of this quadratic. Okay, but what happens if we do this? Let's take our most simple parabola right here. And the question is what happens if if a switcheroo. I know that's not an official math term, but I think it makes sense. Let me show you why. What if I write my equation now as y equals, and notice here 2 is the exponent. What if 2 becomes the base? And what if x becomes the exponent? This switcheroo is what we call the exponential function. And let's give it a definition. It's the exponential, or it's an exponential. I should be more precise. An exponential function has a real number as the base, and the variable let's write this, the variable as, whoops, wrong button, the variable as the exponent. So what we've written here, y equals 2x, is one example of an exponential function. We're going to take a look now at 4 exponential functions. No, sorry, switcheroo should be a question mark. What if there's a switcheroo? Question mark. Okay, now let's take a look. We're going to look at 4 exponential functions, and we're going to take advantage of our of our functional notation, because we can give each one its own name. We'll call f of x will be our first one, and it'll be the exponential function of 4 raised to the x. Our next one is g of x, and this one's going to be 4 raised to the x minus 1. X minus 1, all of that is in the exponent. And then the last one is going to be h of x is equal to 4 raised to the x minus 1. So we're going to evaluate these. So let's do this. Evaluate each function for x equal -2, -1/2. What else should we do? Oh, 0. How about a half? And finally 2. So we'll do those 5 values for each function. And we're going to do this because it's going to help us remember a couple of things here. One is we're going to look at, these are our remembers. These are our memory joggers, and why we're doing all of those. Remember, we're going to have negative exponents here. So this will help us to remind ourselves of how to work with those. So we'll look at negative exponents, and we're going to look at fractional exponents. And when we present this, we're going to use what we have learned. Use what has been done. And you'll see this as we progress. It actually allows us to move a little faster through the video, but remember, if things get ahead of you, you can always stop it, pause it, rewind it, and proceed. So let's begin. Our first one, we're going to start with f of x. So I'm going to evaluate f of negative 2. So this equals 4 raised to the negative 2. Now, when we have this, I'm going to just use horizontal notation. Remember that the negative switches the base. So what you have to do is you have to remember that the number 4 as a fraction is 4 over 1. So if you think of it this way, you can flip the base, so the base becomes 1/4, and then the exponent is now positive. So this is how you use the negative exponent. And then remember that 1/4 squared is 1/16. Okay, let's try another one. We'll just go along this horizontally here. F of minus, actually I'm going to put this one over. This one might take a bit. F of minus 1/2. So this becomes 4 raised to the minus 1/2. So again, we're going to need to remember that 4 is 4 over 1. So the problem is now 1/4 raised to the positive 1/2. See how we took advantage of what we had already seen here in these two steps. Writing the 4 as a fraction and then flipping it to get the positive exponent. Now this is a fractional exponent. And we work with those. Remember the numerator. So let's do this. In a fractional exponent, you have some number, we'll call it the base. In a fractional exponent, the top number is the exponent, and the bottom number is the index. And by that, I mean if you write it this way with a radical, the index is the root that you're taking. So if you think about, if we use this pattern here, really this problem is, what is the square root, because the index is 2, of 1/4 raised to the first power? Well, remember that 1/4 to the first is simply 1/4. So let's write that. And actually, I'm going to take a moment here. Let's kind of got this all jammed in here. So I'm going to let's move that. Oops. And then I'm going to fix. Put that parenthesis back. Okay, that looks much nicer. Now, and so remember the 2 here, this 2 is implied. So the square root of 1/4 is 1/2. All right, let's try the next one. The next one is f of 0. Well, this becomes 4 raised to the 0 power, and any number to the 0 power is 1. Okay, the next one is f of 1/2. So this means we write 4 raised to the 1/2 power. Oh, but wait, we just said that the 1/2 power is the same as taking the square root of 4. And that we know to be 2. The last one for f is 2. F of 2. This becomes 4 raised to the second power. This is 4 times 4, and we know that 4 squared is 16. Okay, that's our f's. Next, we're going to move to our g. So let me write g down again. G of x is the exponential equation of 4 raised to the x minus 1. All that in the exponent. So g of negative 2, this equals 4 raised to the negative 2 minus 1. Well, that's the same as 4 to the negative 3. But the negative switches our base, so we have 1/4 to the positive third, and then 1/4 cubed is 1/64. Next one is g to the negative 1/2. This is, let's see, 4 raised to the minus 1/2 minus 1. So minus 1/2 minus 1 is the same as 4 to the minus 3/2. But now a couple things happen here. First, let's make our exponent positive. So now I have 1/4 raised to the 3/2. But this says you're going to take this, you could do it either way. You could cube it and then take the square root, or you can take the square root and then cube it. And if you do that, let's take a look at it. The cubed root, you take the square root, so we don't write the 2 usually, but you can just for if it helps for clarity. It's the square root of 1/4 cubed. Well, look at this. Right up above, we found 1/4 cubed. That's a 64th. Oops. So this is simply the problem of the square root of 1/64. And work out the square root of 1 is 1, and the square root of 64 is 8. Next one is g of 0. Now this one's a little sneaky, so don't jump to conclusions. You have to trust the math. This becomes 4 raised to the 0 minus 1. This is 4 raised to the minus 1, but we know how to deal with that. We flip the fraction. We have, and I'll write the extra step, it becomes 1/4 to the positive 1, which is 1/4. Then g of 1/2, this is 4 raised to the 1/2 minus 1. This is 4 to the minus 1/2. This is 1/4 to the positive 1/2. And we found the square root of 1/2 earlier, of 1/4 to be 1/2. G of 2. G of 2 says take 4, raise it to the 2 minus 1. Well, this is 4 to the first power, or simply 4. One more function we're going to look at. I'm going to put a line. Actually, I'm going to do this just for clarity. Here's our g, the work we did for our g's. Gee, that was a lot of work. Let's bring that down. Just leave it there. Okay. Our next piece is we're going to go through the same process now using h. And h of x, if we looked back, it's 4 raised to the x minus 1. Now, this is another example of using our previous work. Because if I just look at this little bit here, 4 raised to the x, well, we've seen that before. Where? That 4 raised to the x is right here. It's f of x. So in other words, we've calculated all 5 of those already. All we have to do now is subtract 1 from each one. So let's go up to the top, or down here, and we will run through these now. And we're going to use what we've done, h of minus 2. So this is 4 to the minus 2 minus 1. Well, 4 to the minus 2 up above, let's see, what did we find? F of negative 2 is 1/16. Oops, I'm sorry, that was a little fast. We found that right there, it's 1/16. So we can use that here. This becomes 1/16 minus 1. This is 1/16 minus 16/16. So our answer becomes negative 15/16. Okay, h of negative 1/2. Well, this is 4 raised to the negative 1/2 minus 1. And let's go up above and see what we came up with there. We came up with the f of negative 1/2 is simply a half. Okay, so we can use that down here. 1/2 minus 1 is minus 1/2. Okay, h of 0 is 4 raised to the 0, subtract 1. And then, well, we know 4 raised to the 0, that's 1. minus 1 to get 0. H of 1/2, this is 4 raised to the 1/2 minus 1. And I'm going to pause here for a moment. I try to be really careful with my penmanship, but I often see people when they'll get a little careless and they write 4 raised to the 1/2 minus 1. Well, pretty soon, if they forget that they're working with exponential functions, they might look at that as 4 times 1/2 or 4 and a half. And so I would encourage you, if you're making mistakes, it might simply be that your penmanship got the best of you and fooled you. So instead of erasing that, I'm going to put a red X through that. So that's a red X. So this is careful penmanship. That's a word you don't hear very often anymore, especially with how often things are typed. But penmanship, how well you write. So 4 to the 1/2, that's the square root of 4. That's 2. Subtract 1 to get 1. And our last one is h of 2. I don't even think we need to check back, because 4 squared minus 1, we can handle that. 4 squared is 16. We're going to subtract 1 from that to get 15. And that is the exponential equation, and how you use it using negatives and negative exponents and fractional exponents and whole number exponents. Hope that helps. Thanks for watching.